dear all, I'm Gary from NINGBO PROCOLOR. We are one of the biggest high-performance solvent producers in China. Our products and services are mainly focused on plastic, synthetic fiber and film, and inks, especially transfer printing ink. Really happy to see you here watching this video. In this series of videos, we'd like to share with you our knowledge of colorants used in plastics. On the previous lecture, Eric shared with us how chemical structure influences heat resistance, and today we will continue the topic about it. So here is the heat resistance, lecture 2. Let's start with the third factor, heat resistance. It's related to the crystal form. For instance, the alpha-type structure of pigment blue 15 is an unstable structure, and its heat resistance is only 200 degrees. But what if its crystal form changes into an stable beta type? The heat resistance of pigment blue 15-3 with beta type can reach 300 degrees. Fourth, let's see the relationship between heat resistance and particle size. The original particle size of organic pigment also has a great influence on the heat resistance. Generally, small pigment particle size with larger specific surface area results in high coloring strength and low heat resistance. On the contrary, large particle size with small specific surface area results in low coloring strength and better heat resistance. The relationship of particle size and heat resistance of pigment red 254 is shown in the figure below. We can easily find out that bigger particle size contributes to better heat resistance, but the cost is color strength. Current heat resistance is related to resins. The paralleling series of pigment red 149 has different performance when used in different resins. In PC, the heat resistance is 300 degrees, but only 250 in EBS. Many of the resins experience discoloration and yellowing due to thermal degradation. In particular, when determining the maximum heat resistance of current, we must think about to use antioxidants to prevent the stability of resins and currents. Sixth, heat resistance is affected by additives. Processing plastic material is different from the standard resin used in experiment. In fact, the components of one-coloring plastic material may include filler, plasticizer, dispersant, antioxidant, stabilizer, and flame retardant. Of course, plastic and colorants are the main parts. Not all of these components are chemically inert, and any one of them can more or less affect the heat resistance of both colorants and plastic. For example, titanium dioxide is often used to adjust the color or increase the opacity of products. Some pigment mixed with titanium dioxide not only result in color shade change, as well as heat resistance change. The figure below shows the heat resistance of pigment violet 37 decreased significantly after adding titanium dioxide. Clearly, mixing with it, the performance of PV37 is weakened. 7. Heat resistance is related to the time of heating. According to the standard test method, the residence time of colorants is always set at 5 minutes, which is longer than the normal production processing time. Our experience shows that the colorants can be processed at a temperature slightly higher than empirical data if the residence time is very short. As we know, in the injection molding process, the structure of injection machine requires a minimum size as well as a necessary screw volume. However, for technical and economic reasons, it's inevitable to produce many small-sized products with larger injection machine. So the melted material may be remained in the machine for more than 5 minutes if they are not completely extruded. Discoloration occurs in this situation even the detected processing temperature is lower than the empirical data. Also, it's common to see recycling use of the material from the nozzle. We must pay attention to this because each repeating heating will cause thermal damage on colorants. Using hot runner is another reason why discoloration happens in the injection molding process. The time spent in hot runner should be added to the total residence time. The total residence time must be short enough to avoid any discoloration. Thus, poor design in photopolymer structure is also one of the causes of discoloration. For example, the nozzle or other parts of the photopolymer are small in size. The friction heat caused by them will be difficult to calculate and control. As a result, excessive temperature will lead to thermal damage to colorants and plastic. Finally, also pay attention when using two-screw extruder to produce color master batch. In order to improve the production, the length diameter ratio and the mixing section are often increased, so the residence time of colorant increased too. Eventually, the risk of thermal decomposition of colorant getting higher. As we recommend, preventive measures should be taken to avoid any thermal damage. Moreover, in the twin screw and high-speed extrusion process, the high shear force contributes to the rising of material temperature, which will cause part or even complete discoloration, and also migration, diffusion, and frosting. Okay, let's make a summary of today's lecture. First of all, heat resistance is one of the most important factors of plastic processing. Second, the method to test heat resistance is based on EU 1287722 standard or China standard. Third, the factors that affect heat resistance include chemical structure, crystal form, particle size, dosage, resins, additives, and related application conditions. For more information of solvent dyes and pigments, please check our website.